Hello students and welcome to the discussion of the solutions of open mock test JEE Advanced, and we'll be covering the paper number 2 code B. So let's talk about the first question. If you see the first one, it has been given the 37th question. If there exists a chord of parabola y is equal to ax square plus bx and a comma b belongs to R, a is not equal to 0, b is not equal to 0, such that the endpoints of the chord are p comma q and q comma p for some p comma q belongs to R, and p is not equal to q, then the least possible positive integral value of b is going to be what? So friends, here if we talk about the concept being used, you see it's a very interesting one. You have been given the parabola, right? So this is the parabola I'm talking about, right? And we have 2 points here. You can see this is the point and this is the point. These are the 2 points on the parabola which are the end points of the chord. So that is going to be p comma q, right? And this is going to be q comma p. Fine, this is what we have. Now if I talk about this chord, and the interesting part is because endpoints are p comma q and q comma p. So there's a switch. Can you see that? P comma q and q comma p. So they are image of each other. On what is the mirror? So the mirror line is y is equal to x, right? So this is how it goes. Fine. Now this is the line I'm talking about. So this is y is equal to x. Now if I talk about the equation of the chord, okay, this chord, so this is going to be how much? This is going to be of the form y is equal to minus x plus lambda, right? This is what we have. Now what we'll do, we'll just solve this equation 2 times. How we'll solve it? We'll take this equation with the given parabolic equation. We'll get 2 quadratic equation in terms of x and y, and then we'll find the condition. We'll use the condition of common roots in this case. So how to go about this part? See, if we take this equation y is equal to, I have ax square plus bx, and this is equation number 2 we have, right? Now y is equal to this, if we substitute here the first part, so that means it becomes minus x plus lambda, and this is going to be ax square plus bx, right? This is what we have. Or we can write it as ax square plus b plus 1 times x minus lambda is equal to 0. So this is one quadratic equation in terms of x we have, right? Same way, we can take x is equal to lambda minus y. So we put x is equal to lambda minus y, 2, right? This is what we have. Now we can write it as y is equal to a times lambda minus y whole square, okay, plus b times we have lambda minus y. Can you see that? So this is x, and we take on that side, that becomes lambda minus y. So once you simplify this, we get ay square minus of 2 lambda a plus b plus 1 times y, and this is a lambda square plus b lambda is equal to 0 we have. And this is going to be the equation number 4. Both the equation have both roots common. So if you have both roots common, then what is the condition for 2 quadratic equation have both roots common? Is a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So that means I'm talking about something like this. This divided by this coefficients, b plus 1 divided by this, and then we have minus lambda divided by this, right? So once you use the condition of common roots, so what we get lambda to b is equal to how much? We have minus of b plus 1 divided by a, right? Using the condition of both common roots. Now for roots being real, we have d greater than 0. Which equation? We are talking about this equation, right? Now if I talk about this equation, we have d greater than 0, that means b plus 1 whole square we have, and we can write it as plus 4a lambda, which is greater than 0, right? So we substitute this lambda here, you can see, then once we get this, we get the values of b here, because we need to find the least value of b. So that is what we have to find. What we have to find? We have to find the least possible integral value of b. So that means we just substitute the value here, b, and then we come out with this part. B belongs to, we have minus infinity, this is minus 1 union 3 comma infinity, right? So if you talk about the minimum 3 comma infinity, the immediate positive integral value, the minimum value will be what? That is going to be what? 4, right? So this is the answer we have of this question number 37 we have, right? So let's talk about question number 38. So first of all, let's read the question first. Consider the point A 3 comma 4 comma 5 on the plane 4x minus 3y is equal to 0, and it has been represented by P1. Then we have the next part. We have a point B minus 4 comma 3 comma 1 on the plane P2, that is 3x plus 4y is equal to 0. If P is the point on the line of intersection of P1 and P2 such that AB plus PB is minimum, then the z coordinate of the point P is what? Okay, so this is what we need to find it out. Let's draw the plane first. So if we just talk about the plane here, friends, let's understand. Okay, it's a very interesting problem. We have the plane here. This is the plane I'm talking about, right? This is the plane. These are the two planes we have. Okay. Now, so this is plane number 1 and this is plane number 2, right? This is plane number 1 and this is plane number 2. Say A here, which is like satisfying this equation of the plane P1, 3 comma 4 comma 5. So this is the point A. So let me take this point to be A here. And then we have a point B, right? This is how we can write it down, isn't it? Now friends, the thing is that there's a point P on the line of intersection of P1 and P2. Line of intersection is the z-axis, right? Right? Is z-axis. Now, if I talk about this part, so let's drop a perpendicular here. Let's drop a perpendicular here. This is how it goes. So this is the thing we can just talk about, right? Now, when you drop a perpendicular, because this is the z-axis, what will be the point here? So let me take this as N2 suppose, and this is N1. And P is a point on the line of intersection of the two planes such that AP plus PB. So P is a point on the line. So let me take this P to be here, suppose. Okay. And if we talk about the next part, so here what we can take, we can just join it, right? We can join BP then AP, isn't it? Fine. The point N1, so we can take N1 here, 0 comma 0 comma 5, right? This is what we can write. Fine. Now we have N2. What is N2? N2 is 0 comma 0 comma what? We have 1 here. So this is N1. We can just talk about the ratio here. You see, this is N1, A and 1. So if we talk about A and 1, friends, let's talk about A and 1, right? So A and 1 is going to be 5. Then we have B and 2 is going to be 5, right? So why it is so? Let's have a look at this. So if we say this is equal to 1, what does it mean? It means that the perpendicular distance from a point on a plane, right? So that is going to be like what we use the concept of this part, AX1 plus BY1 plus CZ1 plus D whole divided by under root of A square plus B square plus C square, we write, isn't it? So if we have this point B here and we have to find this distance and this distance, we can use this because the equation of the plane is also being given to us, right? For minimum of, so we can write it in this way, for minimum of AP plus PB, P must be dividing right the line joining N1 and N2 in ratio 5:5. That means P is the midpoint of, so P we can say the midpoint. This is the midpoint then, right? This is the midpoint. So that means we are talking about the midpoint. If we talk, this is nothing but we have 0 plus 0 divided by 2, that is 0. 0 plus 0 divided by 2, this is 0. Then we have 5 plus 1 divided by 2, this is going to be 3. So the z coordinate is going to be 3 in this case, right? So this is the answer I am talking about, right? Now friends, let's talk about the question number 39. If integral of 0 to 1 minus x upon ln x is x plus x square plus x to the power 4 plus x to the power 8 up to infinity dx is minus of ln k, then k is equal to what? So here, how to go about this part? You see, the interesting part is that it is a infinite series. So, and also this is not a GP or infinite GP. That is what I am talking about. So that means we should come out with a general term in this case. So how to get the general term, right? And that is the most important thing, and the concept which consequently we will be using after that, that is all about the summation part, right? So what we can do one thing. You have been given this 1 minus x. So let me write this as 0 to 1, 1 minus x into x. So this is going to be x minus x square divided by ln x, right? Then we have plus. We take x square and this is x cube divided by ln of x we have, isn't it? Then we have x to the power 4 minus of, we have x to the power 5. Can you see that? This is going to be, again, we have ln x. Okay, this is how it goes. So you have just multiplied the terms, isn't it? Now let me find the general term of this. I've just multiplied the things and I got this. So how to get the general term? So this is basically TR. General term, TR, right? So this is what we have. We have 0 to 1. And we have to bring it in this form, that is x raised to the power 2 raised to the power r minus 1. Fine. Then we have this as minus x 2 raised to the power r minus 1, this is plus 1 divided by ln x, and this is dx we have, right? So this is the TR term we have. Fine. Now we can just take this way also, the next part, 0 to 1. So here the differential of integral concept will need to be used. So here what we'll have, we have x raised to the power 2 raised to the power r minus 1, this is minus 1 divided by ln x, minus of x raised to the power 2 raised to the power r minus 1, this is the plus 1, then minus 1 divided by, again we have ln x, right? This is what we have. This is dx, isn't it? Now here what we can do is, we can take f of alpha to be 0 to 1, x to the power alpha, this is minus 1 divided by ln x beta, right? This is what we can take. The most important thing that we have to find f of alpha. You got it? F of alpha we have to find. We are talking about f dash alpha in this case. So f of 0 is always going to be 0, right? So because this is 0, so x to the power 0 is 1, 1 minus 1, 0, 0 upon anything is always going to be 0. So f dash alpha we have to find, that is f dash alpha is nothing but, we can get it in this way, 1 upon alpha plus 1, right. This is how we can write it. Fine. If I talk about the integral part here, so this is the, because we just take the integral of this becomes f of alpha, and this is ln alpha plus 1 plus c, but again f of 0 is 0, so c is going to be 0, right. So f of alpha is going to be this now, you got it. This is how we can write it. So once we get this f of alpha to be this, that means we can convert this tr in log terms, right. So tr can be written as what? We have taken ln alpha plus 1, right. So that means we have tr to be ln 1 plus 2 raised to the power, because alpha, this is going to be r minus 1, right. This integral I have taken, this integral. Then we have, next one is minus of ln, then we have 2 plus, right. This is 2 raised to the power r minus 1. You got it. So this is going to be ln, and we have 1 plus 2 raised to the power r minus 1 divided by 2 plus 2 raised to the power r minus 1, right. This is how it goes. Fine. Now we can find the sigma here, friends. Can you see that? So once you find the sigma, that is always going to be limit of n tends to infinity, right, because summation infinite series. So this is going to be minus of ln 3 will be getting. So if you see here, minus ln k, if we compare with minus of log of 3 to the base e, this is always going to be what? This is always going to be 3 beta. So the k, because we have found out minus of ln 3, so k is always going to be 3, my dear students. Fine. So this is the final answer we have, that is we have k to be equal to